Hello all. In this class, let's start a simple exercise with the help of a DC source, and we'll connect three resistors in series with the DC source, and we'll find out what's the value of the voltage and current that is passing through the circuit. So firstly, this is the login screen you can find. Once you find the login screen, you need to go for the DC source, that is the main component. So here you can see there are a lot of number of parameters you can observe here. From here you can click here. It will show a database. In this database I required a DC power, so I'll take a DC voltage source. If I click OK, and a battery will come like this, and it can change the voltage also. Suppose if I want to go for 100 volts, I can keep the 100 volts here. So there are a lot of parameters that can be changed here. So for time being, I'm just considering about only the DC voltage, so I'm taking 100 volt DC voltage. After that, I would like to take three resistances of different values. So, and after this one, you can say place basic option here. You click on this option and you can find lot of the values of resistance that you can see. That is starting from milliohms to ohms and then to mega ohms. So let me take in two ways. Firstly, I'll take for 1 ohm. So for 1 ohm, I'll keep here the circuit, and after that I'll take for 2 ohm. So and see, you might be wonder that why these values are 1.47, 1.43, 1.5, why it is not in a sequential fashion. You might have a doubt in your mind. Basic thing is the MultiSim usually replicates whatever the components that is available in the market. So these are the values that is available in the market, so that is the reason why we are taking all practical components. So for another thing, I'll take 3 ohm of resistances, and I'll keep here. After keeping all these things, let's close this and let's connect one after other, and let's connect one after other, let's connect one after other, and then let's connect back to the source. So while you are making any kind of circuit, ground is mandatory. So let's take the ground. So by clicking the basic option, and you can see there are a lot of parameters are there. In this one, go for the sources. In the sources, you can go for the ground, and you can take the ground and you can connect the ground here. So our main aim here is to find out the current in the circuit. So to find out the current in the circuit, obviously we need to connect a voltmeter in series the circuit. So for this, just right here, if you can see here, you can click on it and you can get a equipment. So if you double click in, it shows a multimeter. So here you are having various ranges, ammeter, means a current, voltage, resistance. For AC as well as DC, you can find out. So for time being, what I want is I want to find out the value of the current. So I'll keep A. So as you know, the ammeter is always connected in series with the circuit. So I'll remove this part, and the positive terminal I'll connect here, and the negative terminal I'll connect here, so that if I take here the circuit, so the ammeter is connected in series with it. So this is the multimeter or ammeter where you can connect. So once you connect this, now you need to find out the value of the current that is flowing through the circuit. So for this, just you need to run the circuit. So by pressing the run button. So once you run the button, you can observe here that simulation is running, and you can double click it, and the value of the current is 16.667 amperes. Now let me tell you how whether this is giving correct or not. You can cross check. So by using our basic class, I is equal to V by R. Let's take a calculator. In the calculator, we need to connect V by R. So 100 is the voltage divided by R, 1 plus 2 plus 3. Since these are in 3, the effective resistance is R1 plus R2 plus R3. So 1 plus 2 plus 3 is 6. So that is 16.66667. So if you see the ammeter 16.667. So both are coming correct. So this is how you can find out. Also one more thing, in practical situations, if you want to find out how the waveform is coming, you can go for directly the oscilloscope. You can see here, you can see a tectonics oscilloscope is there. You can take the oscilloscope here, and it's very difficult for you to see what kind of components that's there in the oscillator. For this reason, you just double click on it. Once you double click on it, the practical oscilloscope that we used in our general labs, you can see here. So it has 4 channels: channel 1, channel 2, channel 3, channel 4, and it has various options. You can play with all the options, and for time being, if you want to switch on and switch off, this is the button. Okay, so this is right now is an off condition. I'm making it off on condition. So what I want to do is, I want to connect channel 1 and the ground to this resistance, and I want to find out how much value of the voltage is there. So what I'll do is, I'll take the channel 1 I'll connect here, and I'll take ground. So if I want to find the total value of voltage, okay, total value of voltage means the voltage drop across this one plus the voltage drop across this one plus the voltage drop across this one, I can find like this way. Now if I run the circuit is running here, and you can see you can go here, see the option is called auto set. Just go for auto set. So once you go for auto set, so here we have set the channel 1, each box is for 100 volts. So it is showing 100 volts completely. The channel 1 is 100 volts. Let's stop it. Instead of that, let's change it to 110 volts, and let us find how it's changing. So I'm changing it to 110 volts. Okay, and I'm running the circuit again, and I'm double clicking here, and see, if you connect it to channel 1, this will be highlighted, ground on channel 1. Now go for auto set, and once you go for auto set, it's showing the channel 1 voltage. That means each box, see here you are observing, no, this one box is 100 volts. If 2 boxes are there, 200, 3 boxes are 300, means each box is of 100 volts. So since I am getting the channel 1, how much voltage you are getting, you can find here the channel 1 voltage is 110 volts. So likewise, you can find out the voltage by using the oscilloscope, and you can measure channel 1, measure. So whatever you want to measure, what type of source frequency, whatever you want to measure, the period, the main voltage, the peak to peak voltage, all these things you can measure with the channel 1. So like this fashion, you can even check everything and measure everything. Also, and you might have a doubt, suppose how much voltage that is getting dropped across the resistance R1. So then for this, you just click on the channel 1 probe and the ground probe. Instead of connecting the ground probe here, so stop the circuit, delete the ground probe, take the ground probe to R1. So thereby you can find out the voltage across only the particular resistance. So here, and go for the auto set. So the voltage is 18.3 volts, and each channel is of 5 volts. 5 volt, see here the channel 1 is, each division is of 5 volts. So the total voltage is 18.3 volts. Let us check whether it is correct or not. So the total current in the circuit is 18.33. 18.33 into 1 is 18.3. So 18.3 volts. So it is 18.3 volts. So our assumption is correct. And moreover, you can observe here, you are able to see what kind of waveform you are giving. Instead, you stop the circuit, and instead of giving the DC voltage, you may give the AC voltage also. Okay, so instead of giving the DC voltage, you may give AC voltage. And also what you can do is, you can plot the characteristics. So for 100 volts, you just take what's the value of the current, what's the value of voltage across each resistances. For say 120 volts, repeat the same. Like this, with a 10 intervals of time, 100 to 200, take the voltage drop across each resistor and take the current and plot the graph between voltage and current. This is how you can do it